Well, hello again. In this example, you will learn how to develop diaphragm load diagrams based upon externally applied loads. We're going to look at this two-story low-rise hotel building. Notice the dimensions, 90 feet, 45 feet. We've got story heights of 10 feet each, and then the roof has a rise of 3 feet over its particular distance. You can see a dashed line in here where the floor is located. What we're being asked to do is sketch the loading diagram for the roof diaphragm, and that is based upon the loads that are being applied to the building as such. So if those are pressures on the one side of the building, we need to know what that does to the diaphragm as far as the load is concerned. We are also being told in the problem definition that we are to assume that the vertical lateral force resisting system is around only the perimeter of the building. That tells us the diaphragm is only being supported on the outside. The first step is going to be to identify the division or the tributary height to that roof diaphragm. You see where the floor diaphragm is labeled. In fact, let me go ahead and kind of finish that out for you around here. So we see where the floor diaphragm is. The roof diaphragm is right up here, and it of course follows something like this. What we're going to do is to identify the tributary height. We will take a line and we'll draw it halfway between the location of the floor and the location of the roof. We'll come over here with a horizontal line. Maybe if you want to view it this way, it's halfway there. And so this dimension from that point to that point is half of 10 feet, which is 5. You'll recall that 10 feet was the height between the roof and the floor. Okay, so we've got 5 feet there, and then you will recall that we rise another 3 feet to get to the ridge. And so really, if you want to think of it this way, is that our tributary area to our roof is this, where that's the 5 feet there, and it will rise up to 8 feet. In fact, let's look at that area head on. Okay, so here we are. We've got this as 5 feet, so this is just the tributary area to the roof, and it rises another 3 feet. If we look back at this sketch, we will notice we've got a lower pressure over that 36 feet and then a higher pressure over the 9 feet. So let's go ahead and delineate that even here on this sketch. So we'll go 9 feet here, 36 feet here, and this is that region that has the higher pressure. You'll find it helpful in this case to know what that height is, and just using similar triangles, we could compute that out to be 6.2 feet. Okay, so what we need to do is go ahead and get the quantities. And I'm not going to compute the quantities on this yet until we actually take a look at what the diagram for the diaphragm looks like. We know that the supports are on the perimeter, so we've got kind of those extremes here. This is a top view of it, so let's even go ahead and dimension. We've got a center line dimension here of 22.5 feet, and then you'll recall we had this 9 feet there, and that will then leave us a balance of 13.5 feet. That's me just taking this information and kind of taking half of it here, 22.5, and then breaking it up as such. Okay, and then we are going to go ahead and sketch what that load looks like. So we can come up here, that is to that 22.5, that's where it peaks out and it starts to come back down. Now we are tempted at this stage to just go ahead and continue drawing it down like this, but that would not be correct because there is a different pressure that occurs right in here, and so we'll bring it down here. We know that it rises in pressure, and then it will come back down and do something like this. Okay, so the trick is going to be to get those appropriate quantities. And that's where we're going to get it back here. So I'll get a quantity right here based upon the tributary height. So let me just do it like this. We've got 5 feet tributary height at this location times 32.7 PSF, and that will equal 163.5 PLF. We've got this location, tributary height of 8 feet, 32.7 pounds per square foot, and that will equal 261.6 pounds per linear foot. Let's go ahead and make this easy on ourselves. I'm going to jump down here to this end where we have a 5-foot tributary height. Now the pressure there, we recognize that as being 49.1 PSF, so let's go ahead and write that down. Giving us 245.5 PLF. Now this location is the one that's a little bit tricky because just to the left of that line it has a pressure of 32.7 PSF, and just to the right has a pressure of 49.1. So we will go ahead and treat those separately here. Let me get the one just to the left. 6.2 feet tributary height times 32.7 PSF gives us 304.4 PLF. And then we have this other one, same tributary height, but different pressure, 49.1 PSF, giving that to be 304.4 PLF. I see we got that one off just a little bit. That one was actually 202.7 PLF. Okay, so to finish this out, all we're really needing to do is translate those quantities over here to our load diagram. 163.5, 261.6. All these are units of pounds per linear foot. Down here, that's the 202.7. Up here, 304.4. And finally, 245.5. Once again, all these in PLF. Now you'll notice what I did is I sketched all this on the actual dimensions of the diaphragm. So with 90 feet in this dimension. It is very common to analyze diaphragms as if they are beams, and so we're going to squeeze this dimension and just create a sketch that looks something like this, so it confuses us a little bit less. Okay, I'm not going to take the time to translate those numbers over here, just rather to show you that basic shape and that our diagram now takes on this particular look. And that concludes this example. As always, it's a beautiful day for studying structures.